Hello everyone, great to have you back, or if it's your first, welcome aboard. Time to get started with the engine. So this is what we will be building in this section from here to here. So here you see all the parts making up the Mercedes engine, and here you see a finished piece sitting in our unplugged version. So let me show you that, how beautifully detailed it is. And it sits even on its original engine bearers, just like the real thing. So that's what we will be building in this section. Just let me put it back on the undercarriage legs. Voila. The engine is a perfect starting point because it strikes that nice balance between straightforward and more intricate parts. So a great way to ease into support removal and cleanup. And following our Gothaforce design philosophy, most of it just snaps together. So clean, enjoyable, and effortless. But before we dive into the details, let's rewind a bit because an engine, that's where the whole journey started. AirPods again? No, these are older ones. The ones you saw earlier were these. Now, what do AirPods have to do with an engine? Just let me show it and you will see. Think summer of 2023, just returned from Greece to pitch the overall vision and strategy. It went great, but then you cannot expect that everybody immediately jumps on board, especially with a concept this different. So what do you do? Well, as we said in an earlier video, prototyping or small steps so people can actually see an idea taking shape. So what you see here is a plastic injection molded Mercedes engine from a well-known brand, to which we've applied some scratch building bits just as a prototype to demonstrate how things could snap together instead of having them glued together. Now, I'm not going to show the entire build, also because bits have broken off through multiple use, and well, I mean, it's a prototype. But I must admit it felt a bit like a trip down memory lane, as it's been a long while that I opened this, and it was kind of peculiar to see how much of the DNA it already carried, both in terms of how things come together and also how it presents. Now, most of it is just common sense, so let me start with the two crankcase halves. Although I admit I'm a bit proud of this because it's a bond where form follows function. So the male joints form our logo. And then the fact that there are multiple joints which are closely next to each other automatically has that effect that things stick better together than just a single joint. So let me just demonstrate that. You see? So that's the Gotha joint. Now, unfortunately, the Gotha joint didn't make the cut, and that's because Costas never wants to listen to me. No, seriously. I mean, if you look at the end result, it's simply on another level. I showed this on several occasions during shows, so when the supports are removed, and hopefully you will have that experience that when you snap it together, you can hear that clicking sound. I mean, it's even better than Lego. So let's just hope that the Gotha joint eventually finds its way in some of our products in the future. Now, the second one is a proof of concept of what I call asymmetry, other than the longer pick, which again has that effect of having things stick better together. And haven't we all had that experience where you have parts which are not very clear in the direction you apply them, the instructions are not very clear, you're enthusiastic to put it together, you glue it together, only to find out that it was wrong, and then you can throw it into the bin. So that's what asymmetry is all about. So let me demonstrate it here again. Up. And you cannot do it the wrong way. Also in the end product, we have done this because one of the cylinder joints is hexagonal instead of like a circle. Personally, I'm a big fan of asymmetry because Just like a GPS in your car, it has that subtle way of saying, well, I mean, don't worry, we got you covered. And, well, the well-known brand here we're talking about had some of those clever solutions, because if you've ever had the chance to build one of their D7s, I'm sure you must have remembered like the axle with the arrow, which is a really very clever solution. Okay, so let me just finish up with the third one. With the inlet manifolds, here too, a bit of a longer pegs. You just click it together, and quite quickly you can have a really satisfying results with clean hands, without the need to resort to blue tack or Tamiya masking tape or whatever to keep things together. So that's how it all started. I mean, it's just a prototype, but it definitely served its purpose. Once we had crossed that stage, it was time for the next step, doing something for real. So we picked the Siemens Halski rotary engine, you know, the one that comes with Aviatik's Pfalz D8 kit. It's a beautiful engine. Gaspatch made it. They have all the plans. So what better starting point could you ask for? So stepping in the shoes of the customer, the modeler, or in this case, even the beginner, we just made a list of possible improvements, sort of as a food for thought. Now, it must have been a sign of things to come. So when we shared the notes for completeness sake, suddenly this was perceived as a personal attack. A bit surprised, because it was all harmless stuff like you've seen before. You know, cylinders with longer picks so they don't fall out during dry fitting. I mean, totally unnecessary if you glue it. So I said, I mean, relax. Once it's built, it's the same freaking engine. This is just about how to put stuff together. It's a beautiful engine, and in fact, that's the whole point. Because the thing is, if you take something which is already very high, just a little notch higher, one could safely argue that the benefit is relatively marginal. So if that's perceived of sufficient value, then that could give you enough confidence to scale that approach to, let's say, a full airplane. And remember, we're still at the stage of initial skepticism. Is this still enough of a modeling challenge? Luckily, Costas didn't see it that way, and of all people, he could have, because they made the engine, and Greeks are proud people. But Costas, I mean, at its heart, he has that engineering spirit, so he took it as a challenge instead. So in about a month's time, or even less, we finally had something to show for real. Unfortunately, this is all I have left from an entire batch of Siemens Halski SnapFit prototypes. I think we even had a second set of those, but it should be enough to demonstrate to you the whole principle. And then second, here's a specimen from Gaspatch Models' beautiful rotary engine lineup. So there's a difference, especially if you already had the chance to build one of those. So these still require glue, whereas this is on another level because it takes things a lot of steps further, because it doesn't even need glue at all. It's 100% snap. So let me get things prepared and organized a bit better so you can clearly see it, and then I'll show you how. Okay, so first of all, we have these here. I mean, you can literally just take them off by hand. Oh, it just shows how easily things get done. And the only thing you need to do is do a little buffing, and it's straight away it's ready to be built. Now, unfortunately, I don't have a crankcase here, but I mean, they all just snap into the central crankcase. I hope you can see it. And the principle that was applied was similar to like what you find on backpacks. So you just click it in. And that's how quickly you can get a very nice result with clean hands and no glue at all. Before we snap the engine together, I got a few cylinders left here. Not enough for a full build, but then it's a nice opportunity to show you something different. First off, when 3D printed parts are properly engineered, usually they're quite easy and even enjoyable to clean up. But in this case, I want to show you how the material behaves in, let's say, harsher conditions, or think stormy weather. Now, I'm going to do things in the wrong way on purpose. The proper method is demonstrated throughout the series and also in a dedicated video on tools, where we go over which tools to use in which situations. But for now, I'll take the rough approach, so the unofficial method. So let's dive in. Now, the first step, and that is recommended, is that you want to always start by releasing the sensitive areas first to free them up from tension. And in this case, that's the two cylinder arms. So let me just do that. And then here, oops, you see how easily it comes off, even by hand. Now, if you're lucky, I've got 5 chances here. It even breaks off cleanly where intended, because they're thin and engineered to just do that. So, and if not, you just clean it up a little, and that's fairly easy. And at the end, you want to smoothen up the contact zone of the cylinder so that it fits seamlessly onto the crankcase. So let me just do the other ones. So I release the cylinder up. You see? Now here I was a bit unlucky, but then again, it's quite easy to remove, and then have another cylinder. So here I've taken them all off. I was only lucky 1 out of 5 with a fully clean snap with no cleanup to do, and one even had like the cylinder arms broken. Now I'm not sure whether this was already the case before I started, because I didn't had a good look at it, but this just is a good demonstration that this is not the right way to do it. So obviously the correct approach is to handle things with proper care. But being too careful can sometimes also work against you. Now think of the Autobahn. Driving at 300k can be reckless, especially if you don't know how to handle a car. But then the granny that does 30k can be just as dangerous. Now, no offense to grannies, of course, but the point is it's sometimes hard to judge or anticipate behavior when it's outside the expected range. So with this demonstration, I just wanted to show you how the material behaves and holds up under rough treatment. And it turns out, as you've seen, that it's more resilient than you might think. Now, if you've watched one of our earlier videos, you may already have guessed it. Time for crowdsourcing, or sending out prototypes to a diverse group of people to get their opinions, because that's the best way to collect meaningful feedback. Now, if you're watching and you were one of the lucky ones, thanks for your efforts. I hope you liked it. But above all, thanks for your candid feedback. Personally, I didn't have the time to build one yet, but I'm pretty confident that some of it definitely made its way into Gaspatch Model's beautiful rotary engine lineup. Okay, so let's wrap things up, and then I'll show you how quickly and easily you can snap this engine together. Now, compared to the glued version, everything has been re-engineered with subtle differences. Now, I don't know if you've had a chance to build a falsiate kit, but there are subtle differences. For example, if you look here, whereas in the glued version, the cylinder arms kind of sit and lean against the crankcase, here we made holes to have them slide through instead. So let me just show you the principle. So let me start here. So what you do is you just push the engine through, and then at the point where the cylinder arms reach the female cutouts, you just make sure that it sits up nicely, and then you push it through. So here again, you make sure at a certain point you go and you push it, you push it through. Now, one of the feedbacks we got from the crowdsourcing group was that the tolerances were a bit too tight in this cutout. But then you also notice how flexible the cylinder arms are. So let me just finish this up here. Again, same principle. You slide until you reach the female cutout, and then you push it through. Same here. You make sure that everything is lined up nicely and you push it through. And here you can see how quickly, I don't have all the cylinders, but here you can quickly see how easily a star is born, literally speaking. And then if you look at the back side, well, here it's broken. Initially, I had a bit of a different concept where the cylinder has like a female cutout, and then the crankcase with positive joints kind of grips into the cylinder to keep them tight. Here, Costas applied the same principle with the buckle, so when you slide it through, it kind of bumps up and then sits tightly. And then you just end up by fixing the crankcase and clicking it onto the engine, and quite quickly you see you get a result with perfectly clean hands and no need for glue. For the crowdsourcing group, I just printed this out because, again, this was a long time ago and kind of a trip down memory lane. We made a briefing also to evaluate the principle. So here you can see where a star is born comes from. Okay, that's it. Well, for one, because the full snap rotary you saw is likely never gonna see the daylight, not even in our upcoming D8. And that's because we probably stretched it a bit too far. And there's also now resin UV bonding as part of the toolset, which we didn't think of back then. So see it a bit as a tribute to a clever piece of engineering, which deserves its moment to be seen. But more importantly, also because it was a defining moment along the journey. Well, you could look at the full snap prototype as a statement of, hey, look how great of an engineers we are, and they are. But you could also look at it from a team dynamics perspective. And then that same prototype becomes more of, wow, that crazy idea you came up to us with. We've heard it, we even thought it over. Sure, we still have our reservations, but let's give it a shot. And here is how it could look like. And the same holds true for me, by the way. Instead of, wow, what a great engine, more like, hey, these guys, they know what they're doing. Because Costas is an excellent modeler. He has also been a judge. So other than mastering the technology, they also know the subject matter. So why did I even bother making all those slides with recommendations on how to do it? Because what I didn't tell you yet is that other than for the engines you saw, over that same summer of 2023, I built an almost complete D7 just from the same angle to see how it could snap together instead of them being glued together, resulting in a document of probably more than 1,000 pages with all sorts of ideas and suggestions. In hindsight, probably a total waste of time because they came up with much slicker ideas of their own. And later on in the series, I'll show some examples of that. So in the end, it all comes down to trust. Yeah, trust. It's that strange animal, especially if one is a bit of a perfectionist or a control freak. Now, trust me, it comes with a lot of downsides and it's very hard to let that go. But then I always try to think of the upside, and that is that you care. And usually that makes a difference, especially if you can channel that care inside a team. Then you can come across such moments, such as an all-nighter, where at some point you think, I need to get some sleep, or even worse, you start yelling at each other. Because on one of such occasions, Costas drove me to the airport at 6:30 a.m. and we didn't share a single word, not one. But then sometime later, when you go out for drinks and you reminisce, and then you start thinking those were probably one of the best moments. So the full snap experiment, it's probably that moment when trust came walking through the door and the team started to gel. Now I've been around And it's something special because it doesn't happen a lot. And the bottom line is that what I would call A-level people, they're kind of self-managing. I mean, if you tell them what to do, then on the contrary, they see that as an insult. So, in fact, the only thing that you need to ensure is that everybody in a team is aligned along a common vision. And when that's the case, well, then the magic can start to happen. Well, the common vision is that big, hairy, audacious goal, or BHAG, which I mentioned in an earlier video in the hopes of early aviation scale modeling becoming the coolest thing on the planet. Now, BHAG is a term from a book by Tim Herson called Think Better. And if you're into books, I highly recommend it because it dives into the innovation process and also how the human brain works. Probably one of the last frontiers in science, with all sorts of hilarious examples. Now, think of a BHAG as something so crazy that in the beginning, people are like, come on, you gotta be shitting me. But then in some odd way, they find their way to rally behind it. And it's also a good way to see how people tend to look at things, whether they see everything always as a problem or on the contrary, as an opportunity or a challenge. And at best, it's something very simple and crystal clear. One of the best examples mentioned is that of JFK in 1961 at Rice University when he said, like, we choose to go to the moon. I mean, it sounds totally crazy at first, but then eventually they did. Now, obviously, it's not to be compared here, but it's a bit of the same. So on my first trip to Greece, I said, I want the best D7 ever built with no glue. A bit of a stretch goal, and aware that it was kind of a bit of impossible. But then it's funny to see that the end result has gone much further than I would have imagined in the beginning. So that common vision, instead of that 1,000-page document with all sorts of recommendations, eventually boiled down to one page, just one, with a simple and clear statement on what we wanted to achieve, and then a bunch of expectations stated in the eyes of the customer, so the modeler. And probably we will include it as a customer satisfaction or customer experience form, because in the end, you're the best place to evaluate to what extent we've been able to fulfill that vision. Now, we're maybe not going to the moon here, and we don't even know where this thing will take us, but so far it has already been a hell of a ride. Okay, so let's get started with the real thing, the engine, and thank you for watching. Bye.